There's a widespread perception that there's some kind of a conflict or contradiction between religion and science. Many atheists confidently assert that there is, and many religious people are afraid that there might be. Now, certainly some beliefs of some religions do conflict with science, but why is there a perception that all religion per se, is contrary to science? I think people are confusing two things. There is a conflict that has been going on for a long time, but it is not between religion and science. It is between religion and a philosophy called scientific materialism. Now, scientific materialism is a philosophy that grew up along with science, was inspired by science, and often wraps itself in the mantle of science. It is the worldview of many scientists and of some people who claim to speak for science. But it is not science. It is a philosophy. Now, the main idea, the central idea of scientific materialism is that the ultimate reality is matter, so that everything that happens and everything that exists can be understood in the final analysis as a consequence of the laws of physics and chance. For some materialists, however, it is not just a philosophy, but a passionately held ideology that sees science as having a saving mission, which is to free the human mind from irrationality, and superstition, among which they count religion. And this account, it means that for these materialists, they believe that they are involved in a grand struggle between reason and its enemies. And we religious people are among the enemies of reason, in their view. Scientific materialism has a well-developed critique of religion that has three aspects, three parts: a philosophical, a historical, and a scientific part. Their philosophical claim is that there is an inherent contradiction between the scientific and religious outlooks, worldviews. Science is based on reason and evidence, whereas religion is based on dogma, faith, and mystery, which involve belief in things that cannot be seen and for which supposedly there is no evidence. Science is based on natural explanations of natural phenomena, whereas religion is based on the supernatural and the miraculous. For them, religion is about myth and magic, and therefore is purely superstitious, and therefore the very antithesis of a rational scientific outlook. That's their philosophical claim. Their historical claim is that religious people and religious institutions have historically tried to suppress science, hold it back. This is powerfully symbolized, in their view, by the Church's persecution of Galileo, and this impression is constantly being reinforced by the battles being waged, especially in the United States, against evolution by fundamentalist Christians. Their scientific claim is that the actual discoveries of modern science since the time of Copernicus have damaged, have undermined fundamental Christian beliefs about the universe and about our place in the universe. As the story is often told, nearly every great scientific discovery has dealt a blow against religion. Copernicus showed that we are not at the center of the universe. Newton showed that the universe is governed by blind and impersonal forces. Modern astronomy shows how small and seemingly insignificant we are compared to the cosmos as a whole. Darwin, they say, shows that there's no difference between us and the lower animals except a difference in degree, not any fundamental difference. Discoveries in fields such as neuroscience and artificial intelligence are expected to show, if they have not already, that the supposed soul is merely the working of the complex of the brain, which is a complex biological computer. And modern cosmology is invoked to argue that the universe could have created itself from nothing by a quantum fluctuation. I'll deal with each of these three strands in turn. First, the philosophical. The philosophical critique of religion is largely based on crude misunderstandings of traditional ideas about God and creation. Let me start with the idea of supernaturalism, the supernatural. Christianity and Judaism were not and are not based on supernaturalism, if you mean by that a rejection of the idea that there is a natural order. On the contrary, scholars tell us that the book of Genesis was written as an attack, as a polemic, against the supernaturalism and superstition of ancient pagan religion. When Genesis said that God placed the sun and moon in the heavens, in the firmament, to be lamps to light the day and the night, it was attacking the pagan religions which worshipped the sun and moon as gods. When Genesis said that man is made in the image of God and is to exercise dominion over the animals, it was saying many things, but in part it was attacking the paganism in which human beings bowed down to animals or to gods made in the image of animals. In paganism, the world was filled with supernatural forces and populated by numerous deities, gods of the ocean, of the earth, of the forest, goddesses of sex and fertility, and so forth. But Jews and Christians taught that there was just one God who was not to be sought, not to be looked for in nature, within nature, but who was outside of nature, and who was not to be found within the phenomena and forces of nature, but who is the author of nature. In this way, biblical religion helped to strip the world of supernatural elements and to make the world into a natural world, and thus helped to prepare the way indirectly for the emergence of science. The biblical religions then taught that there is a natural order which comes from God. And what characterizes this order, this natural order, and reflects the rationality of its creator is precisely that it is orderly, harmonious, and lawful. Consider this passage. Oh, before I continue, how many people know who that priest is standing with Albert Einstein? Raise your hand if you know who he is. Okay, you'll know. Everyone will know by the end of this talk. I forgot to say that. But consider this passage from the letter of Clement, St. Clement, to the Corinthians. St. Clement is traditionally listed as the fourth pope, and this letter was written around 97 AD. The heavens, as they revolve beneath his government, do so in quiet submission to him. The day and the night run the course he has laid down for them. Sun, moon, and starry choirs roll on in harmony at his command, none swerving from its appointed orbit. Laws of the same kind sustain the fathomless deeps of the abyss and the untold regions of the netherworld. The impassable ocean and all the worlds that lie beyond it are themselves ruled by the like ordinances of the Lord. Upon all of these, the great architect and Lord of the universe has enjoined peace and harmony. Or consider this passage from the Christian writer, the Christian apologist, Minucius Felix, writing around 200 AD, in a book that was aimed at convincing pagans to believe in a creator God. If upon entering some home you saw that everything there was well tended, neat, and decorative, you would believe that some master was in charge of it, and that he was himself much superior to those good things. So too in the home of this world, when you see providence, order, and law in the heavens and on earth, believe that there is a Lord and author of the universe more beautiful than the stars themselves and the various parts of the whole world. So it was not the supernatural or miraculous departures from the natural order, but the order of nature itself that were seen as pointing to its creator. The ancient argument was that if there is a law, there must be a lawgiver. God was the lawgiver not only to the people of Israel, but to the cosmos itself. So God says in the book of Jeremiah, quote, "When I have no covenant with day and night and have given no laws to heaven and earth, then too will I reject the descendants of Jacob and of my servant David." So he gave laws to heaven and earth. Psalm 148 tells of the sun, the moon, the stars, and the heavens obeying a divinely given law that will not pass away. The idea of God as a rational lawgiver very likely helped give birth to modern science and to the notion of laws of nature, as is sometimes admitted even by some atheists. For example, the eminent biologist Edward O. Wilson, a great biologist who is an atheist, suggested the following as the reason why Chinese civilization, for all of its great achievements in science and technology, did not produce a Newton or a Descartes. He said, quote, "Chinese scholars had abandoned the idea of a supreme being with personal and creative properties. No rational author of nature existed in their universe. Consequently, the objects they meticulously described did not follow universal principles. In the absence of a compelling need for the notion of general laws, thoughts in the mind of God, so to speak, little or no search was made for them," unquote. And the well-known cosmologist André Linde, also an atheist, has suggested that the notion that the universe is governed by a single law in all of its parts is a product historically of monotheism, or is rooted in monotheism. Christianity does, of course, teach that there are supernatural realities. For example, divine grace, which have effects in the world. But the word supernatural, which means literally above the natural, would make no sense unless there were a natural order to start with. And the concept of of a miracle, of miracles, which are extraordinary events, which go beyond what is naturally possible, presupposes that there is a natural order which determines what is naturally possible and what is not. There is no contradiction, logically, between the idea of miracles and the idea of a lawful universe. For the same lawgiver who established the laws of nature can also suspend them for a sufficiently important reason. There is much confusion today, even among some Christian believers, about the relationship between God and nature. Instead of seeing God as the author of nature, they see God and nature as somehow opposed or in competition with each other. So that if something has a natural explanation, then God has nothing to do with it. And if God is the cause of something, well, then it must be supernatural. That is not the traditional Christian view. In this view where God and nature are opposed or in competition, you must look for God in things that cannot be explained naturally, in things that science cannot explain. This leads to what is called the God of the gaps. God is hiding in the gaps of our scientific, or holes in our scientific understanding. And as science progresses, those gaps are getting smaller and leaving no place for God to hide. So as I said, that is not the traditional Christian view. If God, as creator of the natural world, established its laws and gave to things their natural powers, then he is to be found principally, primarily, in nature itself and in its ordinary phenomena and processes, whose power and working reflect God's own power and wisdom. This is the message of the following passage from the Book of Wisdom. The Book of Wisdom is a Jewish work of about 100 BC, which is recognized as part of the Bible by the Catholic and Orthodox churches, though not by most Protestant churches. For all people who were ignorant of God were foolish by nature, and they were unable to, from the good things that are seen, to know the one who exists. Nor did they recognize the artisan while paying heed to his works, but they supposed that either fire or wind or swift air or the circle of the stars or turbulent water or the luminaries of heaven were the gods that rule the world. If through delight in the beauty of these things people assumed them to be gods, let them know how much better than these is their Lord, for the author of beauty created them. And if people were amazed at their power and working, let them perceive from them how much more powerful is the one who formed them. For from the greatness and beauty of created things comes a corresponding perception of their creator. Notice that the evidence of God, to which this passage points, consists of phenomena that are perfectly natural: fire, wind, swift air, the circle of the stars, turbulent water, and the luminaries of heaven, which mean the sun, the moon, the stars, and the planets. Medieval theologians distinguished two ways in which God acts in the world. He can act directly and supernaturally, for example, turning water into wine. But he can also act through the operation of natural causes and natural processes. And it is the traditional view that God ordinarily acts in that second way, through natural processes and causes. In the words of the famous 16th and 17th century Catholic theologian Francisco Suarez, quote, "God does not interfere in the natural order where secondary causes are sufficient to produce the intended effect," unquote. I'll explain in a minute what the term secondary causes means. We can read it to mean natural causes. So he's saying God does not interfere with nature, the natural order, if natural causes are sufficient to produce the effect that he wants. Now, this principle was important for the founding, which was shared by medieval theologians generally. It was important for the founding of science, for it implied that when confronted by some new and puzzling phenomenon, we should look first for natural explanations. Superstitious people tend to see the supernatural in every strange or unusual event. But this was strongly condemned by the great medieval scientist theologian, Nicole Oren. In explaining the marvels of nature, he said, quote, "There is no reason to take recourse to the heavens, or to demons, or to our glorious God, for as if he would produce these effects directly, any more than he directly produces those effects whose natural causes, we believe, are well known to us." Another great medieval scientist theologian, Jean Buridan, said that when confronted by new phenomena, we should seek first appropriate natural causes. That's why the Catholic Church, for example, does not declare a miracle to be worthy of belief unless it has first excluded the likelihood of natural explanations. Now this brings me to the all-important distinction, theological distinction, between primary and secondary causality. I think the failure to grasp this distinction is the most important reason that people see a conflict between science and religion. Now, one can explain this distinction by a simple analogy. Consider the play Hamlet. In Hamlet, the character Hamlet kills the character Polonius by stabbing him through a curtain. So let me consider this question. Did Polonius die because Hamlet stabbed him? Or did Polonius die because Shakespeare wrote the play that way? It's a silly question. It's an absurd question. And if you laugh, I've given this talk before, and I sometimes take a vote. And I say, all those who think that Polonius died because Hamlet stabbed him, raise your hands, and all those who think it's because Shakespeare wrote the play that way. And sometimes, and a few people vote twice, which of course they should, because they're both obviously explanations, but they're explanations on a different level, and they're not in competition with each other. Hamlet, the character, is the cause of Polonius's death within the play. He's the cause within the plot. So we can call that the horizontal cause. Shakespeare is the cause of the entire play, and therefore of all of the characters, all of the events, the entire plot. He is the vertical cause. In the same way, in an analogous way, not quite the same, obviously, but in an analogous way, the causes within nature that scientists and other people study are horizontal causes, which theologians call secondary causes, natural causes. Whereas God, as the author of nature, is the vertical cause, or in theologians' terms, the primary cause. Again, they're not in competition, they're not alternatives. And so you see from this how silly it is to treat evolution, for example, and creation as alternatives, as both fundamentalists, Christians do, and atheists do. Did this species of animal arise through some natural process, or did it arise because God wrote the script of nature that way? To a Catholic, both. This also makes clear why scientific materialists are wrong to think that believers in God do so without evidence. To a materialist, evidence means either seeing something with our senses, observing something with our senses, or inferring that something exists as the natural cause of what we observe, the way we would observe a compass needle move and infer that there is a magnetic field. Now, obviously, God cannot be seen in either of those ways. He is not a part of nature, which could be sensed, nor is he a natural cause. But he is a cause. He is not a cause within nature. He is the cause of nature. And so nature gives evidence of God in the same way as a book, a novel, or a play gives evidence of its author, even if the author does not appear in the play or novel. I want to interject. By the way, what time did I start? I know it was supposed to be theoretically...
Let's say 6:20.
6:20, okay. I want to interject here some comments on the Christian notion of creation, because there are widespread misunderstandings about it that are relevant to some things I will say later about cosmology. The creation of the universe is not an event in the history of the universe that happened a long time ago. To theologians such as St. Augustine and St. Thomas Aquinas, it is the creation of the universe is not the same thing as the start, the beginning, the opening of the universe. The creation of a symphony does not just refer to the first notes or bars of the symphony. the creator of the symphony, the composer, creates equally all the notes of the symphony. There's a difference between the origin of the symphony, which is the creative mind of the composer, and the beginning of the symphony, which are the first notes. The same with a novel or a play. The origin of the novel or the play is the mind of the author. The beginning of the novel or the play are its first words or sentences. In the same way, how the universe begins, the first events of the universe are really not that important. What they were, as far as creation of the universe is concerned. In Catholic theology, creation is the divine act by which God gives being and reality to the universe, so that it is not a mere hypothetical universe or fictitious universe or possible universe, but an actually existing universe. And that's one reason we should not, by the way, I should interject here in my interjection. Thomas Aquinas, in fact, believed that it was not possible to demonstrate by reason alone whether the universe even had a beginning. He felt that it was philosophically possible for the universe to have been infinitely old, to have had no beginning in time, or to have a finite age, to have had a beginning. But in either case, there had to be a creator. So in his mind, creation is a distinct thing from the beginning in time of the universe. One should not expect that the first events in the history of the universe, which might have been at the Big Bang, or might have been earlier, we should not expect that those first events in the universe were miraculous necessarily. They could have been perfectly natural. The beginning of the universe could have been perfectly natural, in the sense of obeying the laws of physics, in the same way that the first sentences of a novel obey the laws of grammar of the language it's written in, just as much as all the later sentences do. Okay. Now let me talk about history. Is that me? I think I just hit something. Well, now let me talk about the historical critique of religion. The idea that Christianity, and especially the Catholic Church, opposed science and tried to suppress it or hold it back is called by historians of science the conflict thesis. It has been completely discredited, refuted by historians of science. They do not accept that thesis, though it is generally accepted by the public and by academics and by scientists and by almost everybody, except historians of science who know that it is not true. It's a myth. And the roots of this myth lie in the Enlightenment and the contempt that many of its thinkers had for revealed religion. Its growth was aided in Catholic countries by anti-clericalism and in Protestant countries by anti-Catholic prejudice. The conflict thesis was popularized by two enormously influential books written in the late 1800s. One had the title The History of the Conflict Between Science and Religion by John William Draper, and the other was called A History of the Warfare of Science with Theology in Christendom by Andrew Dixon White, who was actually the first president of Cornell University. These two books are dismissed by scholars today as essentially worthless as history, as full of facts, errors of fact and interpretation. One eminent historian calls Draper's book a thinly disguised anti-Catholic rant. The scientific revolution, which took place in the 17th century, 16th and 17th centuries, and gave rise to modern science, did not occur, as many people believe, against religion. It was not a movement against religion. In fact, most of the great figures of the scientific revolution were devout Christians. Of course, I don't have to tell you that Copernicus was an official of the Catholic Church. Johannes Kepler, who famous for his 3 laws of planetary motion, he announced one of these laws that he discovered with a prayer. I thank you, Lord God, our Creator, that you have allowed me to see the beauty in your work of creation. He was a devout Lutheran. Galileo remained, by all accounts, a devout Catholic throughout his life. Descartes, some people say he was not an Orthodox Catholic, though there's no proof of that. He certainly believed in God and in the reality of the soul. Blaise Pascal was not only a genius in mathematics and physics, but a man whose life was transformed by a deep mystical experience and who wrote in defense of Catholic belief against skepticism. Robert Boyle, who's regarded as the first modern chemist, some call him the father of chemistry, left a large sum of money when he died for a lecture, an annual lecture series, whose purpose was to combat atheism. And Isaac Newton, the greatest of them all, spent as much time in theological and religious and scriptural studies as he did on mathematics and science. All of them saw their work as showing forth the beauty of God's creation, not as supporting atheism. And this was true long after the scientific revolution of the 17th century. For example, the two greatest physicists of the 19th century, James Clerk Maxwell and Michael Faraday, were devout Protestants, very devout Protestants. Moreover, the scientific revolution did not spring out of thin air. I should say, before the middle of the 19th century, it's not that easy to find examples of scientists, famous scientists, who were convinced atheists. There were some, like D'Alembert, but very few. Moreover, the scientific revolution didn't come from thin air. It had its foundations laid in the universities of medieval Europe, as has been strongly emphasized by the well-known historian of science, Edward Grant, who died, I think, not long ago, who was not religious himself. It was in those medieval universities that for the first time in human history, scientific questions were studied continuously from generation to generation by a stable community of scholars. There were 100 such universities in the year 1500, and they produced tens of thousands of graduates who were introduced to scientific questions and from whose ranks scientific talent could emerge. As Edward Grant said, it was in the medieval universities that for the first time science was institutionalized. The scientific community and scientific public created by these universities were the soil in which the seeds of the scientific revolution could take root. Because of the Galileo affair, and because it is often taken as evidence that the Catholic Church is particularly against anti-science, is particularly hostile to science, I would like to spend a few minutes talking about a little-known fact that dramatically illustrates the positive role that the Catholic Church has played in the development of science. It is the large number of Catholic priests who made major scientific contributions. So we scientists, we Catholics, I should say, have our litanies, but what follows is not a litany of saints, but a litany of priest-scientists. And I will only mention the most outstanding, and I'm going to skip the Middle Ages entirely for reasons of time. Oops. So let me skip past the medieval scientists. Also, we don't have very good photographs of them. Okay, so let's start in the 17th century. Niels Stenson, who's also called Nicolaus Steno, was Danish by birth. He converted as an adult to Catholicism and became eventually a priest and eventually a bishop, and he was beatified by Pope Jan Pavel II in 1981. Now, as a bishop, he was noted for his asceticism and his concern for the poor. He was considered the greatest anatomist in Europe. Made many discoveries, important discoveries about the human body, especially about the glandular lymphatic system. And several features of the human body are named after him, such as Stenson's duct, Stenson's vein, Stenson's foramina, so on. But his greatest contribution, for which he's considered a founder of modern geology, of the science of geology, was in developing the theory of sedimentary rock in fossils. Someone had caught a great white shark off the coast of Italy. I think I'm holding this too close to the other microphone. Someone had caught a great white shark off the coast of Italy, and they wanted him to do a public dissection of it, because that's what anatomists did in those days. It was too big, so they cut off the head, and they brought the head of the shark to Stenson. And as he was dissecting it, he noticed that the teeth of the shark were very similar to some stones that are found in Sicily and Malta that the peasants called tongue stones that are found in the mountains. And he realized that these tongue stones were actually originally shark's teeth, and that got him thinking. And he realized, he came up with a theory that these mountains had originally been underwater and that they had developed by layer after layer of sediment, and that these layers, which in nature are found at all sorts of different angles, were originally horizontal and in contact with each other. And so he developed a whole theory of sedimentary rock, which unlocked the history, and that the deeper layers were the older layers, and so on, and also the theory of how fossils formed. There's a Google Doodle, as it's called, celebrating the birthday of Nicholas Steno, and you can't see the details, I'm sure, but there are layers of sediment in different colors, and embedded there are tiny little fossils. So Google celebrated this great scientist. Mersenne, I'll be a little quicker about the others for reasons of time. Marin Mersenne, people who like mathematics have heard of Mersenne prime numbers, but actually his greatest contributions were in physics. He is considered the founder of acoustics for many discoveries about the nature of sound, about vibrations. In fact, for one thing, he discovered the law of the pendulum and published it a year before Galileo did. That's one of Galileo's famous discoveries. Marin Mersenne, he also worked on the theory and development of reflecting telescopes. He did quite a lot. His religious house, his convent, became a meeting place of famous scientists, such as Descartes and Pascal. And it was an important means by which scientists in those days learned of each other's work. There was no internet. There were no scientific conferences. There were no scientific journals. One of the main ways scientists learned about each other's work was through correspondence. And Mersenne was actually carried on a very voluminous correspondence with the scientists of his day and helped to disseminate information about what was going on. And that's one reason why the Dictionary of Scientific Biography calls him one of the architects of the European scientific community. So let me mention a few Jesuit scientists. The Jesuits have a great tradition in astronomy. The very calendar we use today was developed by a Jesuit astronomer, Christoph Clavius. Christoph Scheiner was one of 4 or 5 people who discovered sunspots with telescopes around the same time, and he made extensive studies of sunspots, which are still useful today. His data is still useful to scientists today. Here's a page from from his great treatise, his great book on sunspots. It shows shows his observations of a sunspot as it moved across the face of the sun. Each spot shows it on a successive day. You can see there's a gap. That was a cloudy day where he couldn't make any observations. Giambattista Riccioli developed precise methods of measuring time and used them to measure the acceleration of gravity precisely for the first time, and to study falling bodies. He was an astronomer and wrote an astronomical encyclopedia, which became a standard technical reference work for astronomers for over a century. With Grimaldi, who I'll talk about next, he developed a map of the moon's surface, and many features of the moon's, the nomenclature, the terminology for features of the moon's surface was developed by Riccioli and Grimaldi. I shouldn't have told you this. I was at the physics conference in Warsaw, and I asked people in the audience, these are all physicists, and how many people know who Grimaldi was? And only 1 or 2 hands went up out of 200-something physicists. Grimaldi was the man who discovered something called the diffraction of light. If you are a physicist, you know this is an extremely important phenomenon. We teach it in textbooks in college and graduate school. It shows that light is made up of waves. And since we now know that everything is made up of waves, electrons, everything, diffraction is an important effect in all of physics. I show a few examples of diffraction in those pictures on the right. As you can see, the colored bands that you see on CDs and DVDs are diffraction phenomena. So every time you see those, you should think of Father Francesco Grimaldi. Benedetto Castelli was a close friend of Galileo and a pupil of Galileo's, and he had two important students of his own. Castelli is considered important in the history of hydraulics. Now, one of his students, Bonaventura Cavalieri, was himself a priest and contributed importantly to the development of integral calculus. Now, as you probably know, calculus is independently discovered by Newton and Leibniz. And here's Leibniz giving credit to Cavalieри's work as having been a very important basis for later developments. Okay, he mentions Cavalieri and Torricelli, and he said later others, meaning himself and Newton, progressed even further using their work. In the 18th century, we have Lazzaro Spallanzani. He was considered one of the leading biologists of the 18th century. His contributions to biology were very numerous. He was the first to explain the process of digestion. He showed that fertilization in mammals occurred by the union of sperm and egg. It's pretty important. He even did experiments trying to breed various animals. He tried to breed dogs with cats. Some of his less successful work. But he studied echolocation in bats, the regeneration of limbs in lower animals. Probably his most famous work was on disproving, he did very brilliant experiments disproving the theory of spontaneous generation of life. And 100 years later, Louis Pasteur performed famous experiments of his own, but based his work on the earlier work of Spallanzani. There's someone named Oe, or René Just Oe, who is considered the founder of crystallography. An Italian priest named Giuseppe Piazzi discovered the first asteroid, Ceres. It's the largest asteroid, in fact so large that its gravity squeezes it into the shape of a sphere, which is why it has been reclassified recently as a dwarf planet, along with Pluto. And there's a picture of from the Hubble Space Telescope, and back in May, a NASA satellite called the Dawn spacecraft went into orbit around Ceres, and there you see some pictures taken by that spacecraft. He did other work in astronomy, important work, but this is perhaps his most famous. Pietro Angelo Secchi is considered one of the founders of astrophysics. He pioneered the use of spectroscopy to study the sun and stars. In fact, he developed the first classification of stars based on their spectra. It was the standard one for about 10 or 20 years until a better one was developed at Harvard University, which is now the standard one. But the Harvard classification was based on Secchi's. So Secchi is a very important figure in astrophysics history. And a very nice symbol of the harmony between science and faith is that Secchi did some of his groundbreaking work from an observatory that he had placed on top of the famous Church of Sant'Ignazio in Rome. There was an important mathematician named Bolzano who helped put modern mathematics, calculus, on a rigorous foundation. Here's a statement from the Stanford Encyclopedia of Philosophy. An outstanding mathematician and possibly the greatest logician in the time between Leibniz and Frege. Mendel, I don't have to say anything. Founder of genetics. Was a professor at the University of Notre Dame in the United States who helped develop the first synthetic rubber. And here's the gentleman I showed you at the beginning of the talk, speaking with Albert Einstein, Georges Lemaitre, who was, along with Alexander Friedman, the founder of the Big Bang Theory, the central pillar of our theory of cosmology. Amazing. One of the greatest theories in the history of science, the Big Bang Theory. And it was really first proposed by a physicist who was a Catholic priest. That's not very well known, but for some reason. Okay, enough of this. I hope there are others. We have a distinguished priest scientist in this very room. Okay, so I think I've almost run out of time. It's a question of how much time I was going to turn to some of the scientific discoveries, but I could stop here, but I could talk a little bit about some of the scientific discoveries. It's kind of hot in here. I feel hot, but of course I'm somewhat overweight, so maybe. Okay. So now let me talk about the third strand of the materialist critique of religion, that major discoveries, the most major discoveries have dealt blows to the religious view. The most famous is Copernicus himself. We've all heard the story of how Copernicus overthrew the biblical view or the Christian view of the universe by showing that we're not at the center of the universe, of the cosmos. Well, of course, that's an oversimplification because, in fact, the idea that the universe had a center doesn't come from the Bible. Actually, the Bible had a more primitive, the book of Genesis is a somewhat more primitive view of it. The idea that the universe had a center comes from Greek science, from ancient pagan Greek science of Ptolemy and Aristotle. But there was an idea about the structure of the cosmos that did enter Western thought from the Bible. It was not about space and whether it had a center. It was about time and whether it had a beginning. Now, I just want to say, this is not, saying that the universe has a beginning in time is not the same thing as saying it's created. We shouldn't think that the discovery of the beginning is proof of creation. But nevertheless, the Bible did say, in the beginning. And that was an idea. The idea that the universe had a beginning in time was rejected by virtually all ancient pagan Greek philosophers, including Aristotle. And in modern times, it tends to be not very popular with many materialists who prefer the idea of what's called a past eternal universe. And actually, around as of, say, 100 years ago, it looked like all the scientific evidence was pointing towards the universe having had no beginning. Physicists had discovered the conservation of energy, which says that energy cannot be created or destroyed. So whatever energy you have has always been here, will always be here. Chemists had found that the number of atoms never changes in chemical reactions. In Newtonian physics, time, it was natural to think of time as extending from minus infinity to plus infinity in the same way, and that space extended infinitely in all directions. Almost everything known to physicists suggested that matter, energy, space, and time had always existed and always would. And the idea of a beginning came to be seen as outdated religious mythology. The Nobel Prize-winning chemist Svante Arrhenius said in 1911, quote, "The opinion that something can come from nothing is at variance with the present-day state of science, according to which matter is immutable." The Nobel Prize-winning physicist Walter Nernst declared, "To deny the infinite duration of time would be to betray the very foundations of science." I love the pontifical certainty of that utterance. But in 1916, Einstein proposed his theory of gravity, it's called general relativity, and everything changed. In the 1920s, both in the 1920s, a Russian mathematician named Alexander Friedman, and a Belgian theoretical physicist, Georges Lemaitre, who was also a Catholic priest, realized that the equation of Einstein's theory of gravity could give you a universe where space itself is expanding. And Lemaitre combined this insight with observations then being made in the United States by astronomers that showed that distant galaxies were flying away from us at great speed. And Lemaitre proposed what is now called the Big Bang theory. He called it the theory of the primeval atom, but it was the Big Bang theory. For scientific reasons, primarily for scientific reasons, but also to some extent because of a prejudice against the idea of a beginning, it took a long time for the Big Bang theory to really be accepted. But in time, the evidence grew overwhelming that the hypothesized Big Bang did occur. We now are pretty sure that it occurred about 14 billion years ago. Now, in the standard Big Bang theory, everything began at that time. Matter, energy, space, and time itself. Now, it is quite possible, I want to warn you, that it is quite possible that the Big Bang was not the beginning of the universe. There are many interesting speculative models in which the universe existed before the Big Bang, and some models which attempt to describe a universe which has no beginning. However, there are strong theoretical arguments that suggest that the universe had a beginning, either at the Big Bang or some earlier time. They're not proofs, but they're very strong theoretical arguments. So science is now supporting an idea that was once dismissed as a relic of religious mythology. The second development, I'm only going to talk about three. The second has to do with the existence of design in nature. So religious people have always seen evidence of design in the beauties of living things, flowers and seashells, well, formerly living things, the beauties of the heavens, and so on. And they saw those as having been fashioned metaphorically by the hand of God. But modern science seemed to undercut this idea by showing that all of these things we see, all these beautiful patterns in nature, are really the result of mechanisms that depend on combination of impersonal laws and blind chance. So Genesis spoke of God placing the sun and moon in the heavens. But we now know that they formed from clouds of gas and dust that under the force of gravity condensed. Darwin showed how the very intricate and beautiful structures of living things could arise from natural selection acting on random genetic mutations, or he didn't know about genetics, but random mutations. When Napoleon asked the great mathematical physicist Laplace why God was never mentioned in his great astronomical treatise, Laplace famously replied, I had no need of that hypothesis. So it seemed that the laws of nature, physics, the laws of physics had replaced God. That's a very big change in the way people saw the laws of nature. As I said, in ancient times, many people, Christians, saw the laws of nature pointing to the lawgiver. But now, some people were saying the laws of nature by themselves are sufficient to explain everything, to explain the order in nature. And there is some justification for thinking this way, especially when we see the shapes of things such as crystals, seashells, flowers, and so on, or the solar system. Consider the solar system. There's many beautiful patterns in it. All the planets go around the sun almost in the same plane. They all go around in the same direction. They all go around almost in circular orbits. And Kepler, as we know, discovered other beautiful patterns in the solar system. Newton himself thought that some of these patterns had to be placed there, as it were, by hand by God. He didn't understand how his laws could explain some of these patterns. But in time it was shown, Laplace was one of the people who showed this, that actually the force of gravity and Newton's theory of gravity can explain all of these patterns in the solar system. So that's just one example. Now, if we show that all the beautiful patterns seen in the solar system are explained by the laws of Newtonian physics, does that mean the laws of physics, Newton's laws, have explained the existence of cosmic order? No, it's the opposite. It's the reverse. For how did Newtonian physics explain the orderliness of the solar system? It did so by appealing to a deeper order described by Newton's laws of mechanics and gravity, an order that applies throughout the whole universe, not just to the solar system, an order which is mathematically much grander and more impressive than the laws discovered by Kepler. And the laws of Newton's law of gravity eventually was shown to be a consequence of a yet deeper law, which was Einstein's theory of gravity. And Einstein's theory of gravity shows a mathematical orderliness that is even more impressive than Newton's. So the deeper and it's now believed that by many people, almost all physicists believe, that Einstein's theory of gravity is actually a reflection of a yet deeper theory. which many people believe, and there's very strong reason to believe, is superstring theory, whose mathematical structure is so sophisticated that after 30, well, now it's 30 years, people have been studying it intensively, they still don't fully understand the mathematical structure of superstring theory. So the deeper we go into nature, the more orderly, the more structured it appears to be, the more impressive the mathematical order. So, and the more lawful, I should say, also. And you can see this because you could explain Kepler's laws to a grade school student, a relatively small child, in a few minutes. You could even show them what an ellipse is. Newton's laws, you need calculus. Einstein's theory, yet deeper, you need to know about tensors and differential geometry and curved four-dimensional Minkowski space-time and things like that, which are much more difficult. Superstring theory, as I said, is much more profound mathematically still. This is what the progress of physics in the 20th century has shown. The deeper we probe into the hidden workings of the physical world, the richer, more intricate, and more magnificent the mathematical structure we find. And we find it in the laws themselves, in the mathematical laws. In 1931, the great mathematician and physicist Hermann Weyl gave a lecture in which he said the following. Many people think, I think I even have this on. Yes, many people think that modern science is far removed from God. I find, on the contrary, that it is much more difficult today for the knowing person, he wrote this, by the way, in 1931, for the knowing person to approach God from history, from the spiritual side of the world and from morals, for there we encounter the suffering and evil in the world, which it is difficult to bring into harmony with an all-merciful and almighty God. In this domain, we have evidently not yet succeeded in raising the veil with which our human nature covers the essence of things. But in our knowledge of physical nature, we have penetrated so far that we can obtain a vision of the flawless harmony which is in conformity with sublime reason. So when Minucius Felix wrote in the year 200 that providence, order, and law in the heavens and on earth points to God, we should see that the deeper we have penetrated into nature, the more order and law we have seen, and the stronger the argument for God has become. That argument for God. And the last thing I'll speak of, well, it's now an hour. I was going to speak about whether things in nature have a purpose. And it's now easy to see that this idea seems naive from the point of view of, say, Darwinian evolution. It's very easy to be naive and to say, well, it's not naive, but it's easy to look at things in nature and say, the sun shines in order to produce energy for life. That's the purpose of the sun. The purpose of the rain is to provide water for plants, and so on. And then from things having purposes in nature, you say, well, that purpose was part of a plan in the mind of God. In Aristotelian physics, things happened in nature because they were seeking unconsciously, but they were seeking some goal, some end. They had a purpose. Things fall in order to reach the center of the earth. We heal from injuries in order to reach the goal of health and wholeness. When the scientific revolution came, this teleological approach was thrown out, at least in physics, in favor of a mechanistic approach, in which things happen not in order to reach some goal in the future, but they are driven along blindly by causes in the past and the present. This is mechanistic view. But the idea, and so Darwin even took this further. We now know that trees do not exist so that monkeys can climb them. But there were trees and monkeys, therefore some animals evolved the ability to climb them. Okay? The sun didn't exist. To a physicist, the sun doesn't exist in order to give life for life on Earth. It produces light and energy, and living things on Earth take advantage of that. So to a physicist, we don't ask what the sun is for or what its energy is for. Nevertheless, over the last 40 years, physicists have become increasingly aware that this idea of things having a purpose in nature has actually come back. especially in physics, in the form of what are called anthropic coincidences. Over the last 40 years or so, physicists have become aware that many things in the laws of physics are just right to make life possible. And I could give dozens of examples. If the world did not obey the principles of quantum mechanics, for example, it would be very hard to have atoms and molecules that would be stable building blocks out of which you could make living things. There's something called the down quark. If the down quark were lighter than the up quark instead of heavier, ordinary hydrogen would not exist. It would be unstable. The strong force that holds nuclei together, if it were only slightly weaker, we wouldn't have most of the elements of the periodic table. We live in a universe where there are three space dimensions that we can move around in macroscopic distances. If there were more than three space dimensions, it would be probably catastrophic. But if there were more than three space dimensions, planets would not orbit stars in a stable way. They would either plunge into the star or they'd fly off into space. And one can go on and on with a list of these things. There is a way of explaining this naturally, which is called the multiverse, which I won't talk about unless people ask me. But I think we can learn. What we have learned is this: you cannot have a universe that has life in it unless the laws of physics are very special. They can be special in two ways. They can be special in having certain numbers have certain values, certain constants of nature, or they can be special in being the kind of laws that give you a multiverse. But one way or the other, you need special laws if you want to have a universe that's capable of originating and sustaining life. So let me stop there and just say that the real enemy of science is not religion. Fundamentalist religion can be a threat to science. The real threat to religion is not science. It is a certain reductive philosophy called scientific materialism. Actually, historically, science and religion, and the Catholic Church in particular, have been on very good terms, with some notable exceptions, such as the persecution of Galileo. I'd like to quote St. John Paul II. Faith and reason are like two wings on which the human spirit rises to the contemplation of truth, and God has placed in the human heart a desire to know the truth, in a word, to know himself, so that by knowing and loving God, men and women may also come to the fullness of truth about themselves. Thank you. I'm sorry I went late.
Thank you ever so much for such an interesting and such a dense topic.
And too long, perhaps.
Well, we would like to hear you more. Perhaps not one lecture, but
maybe I should have broken that up into two lectures.
Each part of your talk deserves to be a full separate lecture. Okay, and now we can attempt to make this set of ideas perhaps less dense and more accessible to our weak minds, just by asking questions and clarification. So please, if you have some questions, I think that there are a lot of them, but
and don't be shy. It's very hot in here. If you feel you must leave, this is a good time to do it.
First one question.
Please.
Actually, I asked you something you said at the end in passing, that the multiverse theory,
Yeah.
because all of the arguments you made were under the single universe assumption,
Right.
So I would like to hear your comment maybe briefly about
the multiverse?
Multiverse theory. How
Yeah. Do people know what the multiverse idea is? The multiverse idea is this. As I said, many of the things we have traditionally thought of as constants of nature, say the mass of the electron, or the strength of the strong force, and so on. The idea is that these are not actually constants of nature, but can take different values in different parts of the universe. And so in our part of the universe, we can only see, by the way, a certain finite part of our universe because light travels at a finite speed, We can't see more than some tens of billions of light years since the Big Bang. So anyway, in the part of the universe we can see, these numbers take certain values which are favorable to life. But if you were able to look at the whole universe, you would see that there were many different domains or regions where they took all possible values. And so if these numbers take all possible values, then it's not surprising that there will be some place in the universe where they take the right values to make life possible. That's the idea of the multiverse. And there's nothing that is certainly a very strange kind of universe. It's one universe. Don't misunderstand. People who advocate the multiverse believe there's one universe and one set of fundamental laws. But these laws can make things look different in different parts of the universe. The same way, H2O is the same whether it's ice or water or steam. But ice and water and steam have very different properties. So the same laws can make things look very different in different places in the universe. The multiverse idea, I met some religious people attack it or think that it's some kind of atheist plot. They're saying, well, this is a crazy idea that some scientists have thought up in order to explain this obvious evidence for God, that the laws of physics are just right for life. That's wrong. It wasn't just thought up by atheists. In fact, most scientists dislike the multiverse idea a lot, including most atheist scientists. It's very controversial. I happen to think it's a very interesting idea. I and many other physicists think that it has some chance of being correct. But even if it's correct, I don't think it explains away the fact that, as I said, I think it doesn't get rid of the evidence that the laws of nature were designed with the purpose of life. Because, as I said, in order to have a multiverse, the fundamental laws have to be very special. If you invent some set of laws out of your own head, that's what people like me do, theoretical particle physicists, we sit there at our desks and we try to invent laws of physics, hoping that they're the right ones. But if you just invent laws out of your own head, the chances are that they're not going to produce a universe that's a multiverse. So they have to be special. So one way or another, you need special laws, or you're not going to have a universe with life in it. Okay, that's my opinion.
Well, perhaps if I can say something.
Yeah.
The best comment on the multiverse from the theological point of view I ever heard is the following. If God is infinite, he could not be interested in anything else which is less than infinite. So he had to create multiverse.
And in fact, it's an interesting thing. People are very impressed that Copernicus came up with the idea that the Earth is not the center of the universe, but is moving. But in the 1400s, a cardinal who was a great theologian and philosopher named Nicholas of Cusa said that because God is infinite, the universe should be infinite to reflect his infinity, and that there is no center to the universe, no center, and that all bodies, the sun, the earth, the moon, and everything is in motion in an infinite universe, which is even more modern. I don't want to take any credit from Copernicus, but it's even more modern a view. That was the 1400s by a cardinal, a German cardinal.
Please.
Yeah.
Okay.
Yeah.
I can sit or I can.
Sure.
Okay, I got a question because you recently mentioned this French father, French priest,
Or Belgian,
Belgian,
Lemaitre, yeah.
who is believed to be the inventor of the theory, the Big Bang theory. So I have a question: how does Stephen Hawking what Stephen Hawking has to do with this whole Big Bang theory, or because maybe this is my lack of knowledge, because I'm not a physician, but I've read some articles about Stephen Hawking, and it's not based on this movie, so
Right.
you will know.
Okay.
So
What was his role?
Yeah, what
Okay.
was his role?
Okay, first, the Big Bang, Lemaitre proposed the Big Bang theory, what we now call the Big Bang theory, I believe Father Heller may correct me, I think it was 1927. Alexander Friedman, this Russian mathematician, his work was done early, 1922 or sometime around there, but they were independent of each other. So it was in the 1920s. The evidence for the Big Bang became really very strong in the 1960s. In the 1960s, it was discovered what's called the cosmic microwave radiation, the cosmic microwave background radiation, which is radiation that's coming at us from every direction in space, and which was then very quickly understood to be radiation that was left over from the Big Bang. It was in the 1960s that cosmologists began to really believe that the Big Bang theory was probably correct, and the evidence got stronger and stronger. So it goes way back, and as I said, already in the 1960s. What did Hawking do? He and Penrose proved some important theorems that showed that if you make certain assumptions, he proved a mathematical theorem that if you make certain assumptions about the properties of matter and so on, and you assume that Einstein's laws of gravity apply, and you neglect quantum mechanics and so on, under certain assumptions, the universe had to have what's called an initial singularity. That is, there had to be a point, a finite time in the past, at which certain physical, in which the universe was infinitely dense, in which it was infinitely hot, if you will, and so basically where the laws of physics broke down, don't apply. It was sort of t equals 0. There had to be a first point in time. But he was simply proving a rigorous mathematical theorem that showed that, because as I said, some people were trying to make models in which somehow maybe the Big Bang wasn't the beginning. Maybe the universe, there was an idea that goes way back to the 30s, Einstein worked on it, where the universe expands, then it collapses, and it bounces, and expands again, and collapses, and bounces, and so on. And where what we call the Big Bang was just a bounce. And so there was something before the Big Bang. But the Hawking-Penrose singularity theorem showed that actually, under certain assumptions, you had to have an actual beginning at the Big Bang. But that he did not invent the Big Bang. That goes way back before that. Yeah.
I will go to the multiverse idea once again. And actually, what do you think about it? Will we ever have any scientific evidence on that idea, which will support it? Or actually, is it possible to even have some evidence?
We'll not have direct evidence of it, because what the multiverse idea says is that regions, we know that these constants of nature, the mass of the electron, the strength of these forces, is the same throughout the entire universe that we can see, our what's called the observable universe. But there's a horizon past which we cannot see and never will be able to see, because light, it's only been 14 billion years since the Big Bang, so light can only travel 14 billion light years in that time, so you can't see farther than a certain distance because the light has not had time to get to us. So we will never observe past this horizon. And the multiverse idea says that there are regions of the universe farther than the horizon where the laws of physics look different, where these constants look different. Well, clearly we cannot directly test that. There are maybe some indirect ways that we could get evidence. I don't know if we can get conclusive proof, but there are ways that possibly, if we're very lucky, we might be able to make some kind of arguments in favor of the multiverse. Personally, I think, and I think most physicists would agree with this, I think we'll never really have, I don't think it's possible to have real confirmation of the theory. And that's the main reason that most physicists hate the idea and say that it is not science, because you can't test it. In fact, I wrote one of the first multiverse papers, okay? This idea of the multiverse was very controversial. In fact, you could probably ruin your career as a physicist by writing papers about it. The first really important paper on the multiverse was written by Steven Weinberg, who is probably the greatest particle physicist of the last 2 generations. And he's a Nobel Prize winner, and he, unfortunately, a militant atheist. He wrote a paper in 1989 in which he used multiverse ideas to explain a certain unsolved problem in physics. But he was Steven Weinberg. He could write that paper, right, and get it published. In 1998, I and some friends wrote a paper which was probably one of the next papers that was important on the multiverse. It was a 4-person paper. 2 of the authors, me and Donahue, were practicing Catholics. One of them was militant atheist. One of them, I don't know what he was. But we had a hard time getting that paper published. The editor of the journal, the referees of the paper, said basically it should be published. But the editor, and I won't say his name, a very well-known cosmologist, said, I am vetoing this paper, which is, I'm taking the unusual step of vetoing this paper. I will not publish it because it is not science, and in fact is fundamentally anti-scientific because it's not testable. But at the same time, we submitted a short version of the paper to a much more elite journal called Physical Review Letters. It was accepted there, and one of the referees was Steven Weinberg. So we had the greatest physicist of our time saying that our paper should be published, while this much lower journal was saying, no, it's not science. Of course, the lower journal had to change its mind, and now papers are published all the time on the multiverse. But in 1998, when we wrote our paper, it was almost poison to do so. So it's and it's still very controversial. Yeah.
Thanks for your talk. I think you made an analogy, Shakespeare being the author of Hamlet, and God being the author of the universe. Now, if somebody asks who is the author of Shakespeare, maybe a possible answer would be his parents. Now, the way you argues for the idea of God as the creator raises the question, who is the author of God?
Okay. There are many answers I could give to that. I've already talked a long time, so let me just say a couple things. First of all, in Christian theology, God is seen as a necessary being. So the analogy is to some true things that are true, but have to be true. They cannot not be true, and necessary truths. And some things are what are called by philosophers contingent truths. So, for example, 317 is a prime number, or 17 is a prime number. That's a necessary truth. It has to be true. You don't ask who caused 317 to be a prime number. It has to be true. The laws of logic have to be true. But there are other things that are true but don't have to be true, didn't have to be true. This table is here. That's true, but it didn't have to be true. It's called a contingent truth. It could have been one way or the other, but it happens to be true. So some things exist. The idea in Catholic theology, Christian theology, is some things happen to exist, but one thing exists by necessity. It is its nature to exist, and that is God. And so you don't have to ask who created God, because his very nature is to exist. Another answer I'd give, and again, this is something that would be worthy of 3 or 4 one-hour lectures. One way of thinking about God, of course, all our ideas about God are mere analogies, but one way of thinking about God is that God is, in Aquinas thought about God in these terms, and so did a great philosopher that I like, Bernard Lonergan. God, imagine an act of understanding that understands everything, all things. It is infinite, unlimited act of understanding that grasps all of reality, all truth, understands everything that can be understood. That blinding flash of understanding is God. Okay? So if you believe that reality is understandable and makes sense, is rational, intelligible, then there must be a mind that grasps it. If things can be understood, that means there's some mind that can understand it. If there's no mind anywhere ever that can understand something, then in some sense cannot be understood. So if everything is understandable, if everything is rational, if everything, as we say, is intelligible, there must be an intelligence which grasps it. So we think of God as existing as necessarily as the truths of mathematics. And so we don't think God needs to be created.
I think we have some
Other questions?
two questions because time is running out.
But I'll stay around.
Next?
Yeah.
My question,
Is this my? I think you might be am I holding this or? I think I found it when I hold it now down to the bottom. It does that.
There is some bad interaction.
Yeah.
so my question, another one, it stands out a little bit from the main topic of this lecture, but I would like to ask you whether or not you've seen lately Interstellar, this movie.
I've been asked that many times. No.
Yeah, because it's funny because I know it's quasi-science, but it is said that they have made some ground discovery when it comes to dark holes.
Black holes. Right?
Black holes, because they are expanding. This is the first belief. Not that they are expanding, but I don't know what was this discovery. What was the discovery? But they say that there is a discovery that the discovery was made, and then the second belief that. You've mentioned that we believe that there are 3 dimensions, and this movie, since you haven't seen it, so probably I won't get any.
There could be more than 3.
Yeah, because
okay.
they believe that there are 5 dimensions.
Okay, let me jump in.
Thank you.
According to some of our theories, superstring theory says that there are 10 dimensions of space. Well, actually, M theory says there are 10 dimensions of space and 1 of time. But of those 10 dimensions of space, am I saying M theory or, well, I'm tired. 10 dimensions of space in M theory. Of those 10 dimensions, 7 are curled up very small, subatomic size. So you can't travel in those 7 direct dimensions.
Sub-dimensions?
Well, they're called compact dimensions. You can't travel in those dimensions more than a subatomic distance. So there are 3 large dimensions, we call them extended dimensions, in which you can move great distances. Darn it, what am I doing wrong? There are 3 large dimensions, and there are 7 little curly dimensions. So when I said that it's important, so we don't know how many dimensions there are, but we know there are 3 large ones. There are only 3 large ones. And so when I said that, I think it's an interference with this thing. So when I said that when I said it's important there be no more than 3 large ones for life, because if you have more than 3 large dimensions, then the force of gravity behaves differently, and it behaves differently in such a way that planets cannot orbit stars. In fact, also electrons would not be able to orbit nuclei, so you wouldn't have atoms and you wouldn't have solar systems. So. That's the thing. I'm not saying there are only 3 dimensions. There are only 3 large dimensions. Should we end here, do you think? Or? No. One more?
Well,
it's up to you.
Perhaps the last question, unfortunately. There are 2. Okay, so the first and the last.
In answer to my question, you say that God's existence is kind of necessary.
That's what Christians believe.
Yeah, so then the question arises actually that if you want to stop at God, why don't you stop in the universe? And that the universe is necessary.
Because the universe is something, we can certainly imagine a case where the universe doesn't exist, or imagine a case where the universe is different. That is, you can't sit in your chair and you can't deduce. If suppose you didn't know anything about the universe, you were born and somehow kept in a dark place and never saw anything about the universe, you couldn't sit there and deduce, oh, there must be a universe and it must have these laws, it must have 3 dimensions, it must be this way, there must be a country called Poland, there must be a place called Warsaw and Krakow and so on. No, all these things exist, but it's also conceivable that they might not have existed. So the fact that they do exist requires an explanation. They didn't have to exist, but they do. So you want to know why. But if you have something that has to exist by its very nature, then you don't ask for an explanation. That's the difference. And we think that God is infinitely simple. And that gets to a whole long discussion. Because he's infinitely simple, he doesn't have structure, he doesn't have parts, he doesn't have, he wasn't put together out of some materials and so on and so forth. God is we believe, an infinitely simple, necessary being. In fact, we believe that God is, in some sense, existence itself.
I think it's a very important question.
It's a very important question.
And I think that the main difference between materialists and non-materialists is exactly that materialists claim that there is an absolute, that is to say, a necessary being, and this is the universe. And non-materialists claim that it's not the case, because there are some strong reasons
Exactly.
you alluded to in this lecture. That
the universe might just exist. The big question of creation is, why does the universe exist? Now, physics, as Stephen Hawking said, cannot explain that. Hawking famously said, before he forgot, he said in his famous book, Brief History of Time, all that physics gives you is a set of mathematical rules and equations. It cannot explain why there is an actual universe for those equations to describe. He said, what breathed fire into those equations so that there's a real universe for them to describe? That's the question of creation. Now, there are two answers to that. Why, as he also said, why does the universe go to all the trouble of existing? Now, there are two answers to that. It just does. There's no explanation. As Father Heller said, the universe is somehow doesn't need to be explained. It just, or you say it was created, there is an ultimate cause, and it's God. And he doesn't need to be explained. So the atheist is in no better position than the religious person. He's in a worse position. Because at least we say there's an infinitely simple, infinite being who is necessary because his very nature is to exist. And he doesn't need to be explained. You have to say all this crazy world we live in where, there's this book on the shelf and all these funny things going on around. That just has to exist. Doesn't have any explanation. I find the first more plausible.
Okay, so my last question, if I understand you correct, your meaning of contradiction between the God and the science is not the problem with the God, but with the science.
No, it's not science.
Ordinary meaning of the science is that there's some kind of experience, like you throw a ball and the ball hits something, and in old times they say because the God decided that it has to be happen that way. And then it came the mathematics and the science and the empirical experience, which say if we use that kind of mathematics, the ball has to hit that way.
Mm-hmm.
So someone will say that the God is not necessary for this experience. We say that this is a science. We throw away the God. And this is the ordinary meaning of the contradiction between the God and the science. The science came and the God is not necessary.
That's not what I say.
Not what you say. It is
Yes, because what I say.
People will mean between the contradiction of the God and the science. And you say that the God can be understood in two different ways, by the mathematics or by the miracles. If we find some kind of sophistication mathematics that can explain what we now think that is miracle, like I don't know, the beginning of the universe.
No, the beginning of the universe is not a miracle.
Ordinary mathematics, like general relativity, we got this infinite beginning of the universe. Like
Okay,
point
let me cut in here.
Equations, like this infinity in the equation. We find some kind of ordinary, more complicated mathematics when we don't see this infinity in the equations. It's not mean that we threw away the gap from this kind of understanding of the universe. just understand the universe in different way, but the God is still in this universe.
And we don't understand the universe we do understand in a different way. What modern science brought us is several things: the experimental method, the use of mathematics to describe nature, and so on. But I say, actually, it's not a different way than the ancients thought of it. The ancients thought of it. I quoted the Book of Wisdom. I quoted the letter of St. Clement to the Corinthians. I quoted Minucius Felix. They all understood back then that the universe has rules, laws, that there's a natural order. They understood that. They said that is the evidence for God. Okay? Many people think that that ancient religion, or that religion, all religion, is an attempt to explain the particular phenomena of nature when we don't have science. So we say, oh, what is lightning? What is thunder? Well, it must be Zeus throwing thunderbolts. Why are there storms in the ocean? Because Poseidon or Neptune is angry. And why are there volcanoes? Because the underground Vulcan is hammering, and gods were invented to explain particular natural phenomena because we didn't have science. That may be true of some religions, but not all religions are the same. The ancient Christians and Jews have always believed that there is an internal logic to the world. There's an order of nature that explains why when certain things happen, other things happen. There's a logic and an order to it, and laws. And there's very little so Christians were not trying to explain, particular physical phenomena. Okay, so I don't really think that story is correct. I think, as I said, the Christians and Jews have always believed that nature has laws, that there's a natural order, and they think that is what points to God. So, I don't know. I'm not sure I answered your question, but it's the best I can do.
Thank you
Yeah.
very much for interesting.